Good morning, children. So today this is your 12th physics, chapter 3, current electricity. Today we are going to cover following topics in this lecture. Topic 1, Ohm's law. Second topic, electrical resistance. Topic number 3, electrical resistivity or specific resistance. Topic number 4, conductance. And the fifth topic, that is conductivity. So let's start with Ohm's law. Now, Ohm's law, this is a law which was given by the scientist George Simon Ohm. He was conducting some experiment related to the electrical circuits, and after a number of experiments he found that he came to a conclusion that the potential difference across the conductor is directly proportional to the current flowing through the conductor. It means if we are having a circuit over here, suppose here we are having, this is our conductor, suppose this is your wire, right? Now across this wire what you do is you are, let me draw it away. This is your resistance, right? This is your wire, and with this wire we are connecting over here a battery, right? We have connected a battery over here, and we have connected a key over here, right? Either you call it a key or you call it a switch. This is the positive and this is the negative, and this is the emitter which is connected in series to the circuit. Emitter is connected in series to the circuit, and the positive of the emitter is connected to the positive of the battery, and the negative of the emitter is connected to the negative of the battery, right? Now we know that voltmeter is always connected across the conductor. यहाँ पे we are connecting in parallel. We are connecting in parallel, and that is your, this is your voltmeter, right children? This is your voltmeter, and again the positive of the voltmeter is connected to the positive of the battery. Here you can see positive side is connected to the positive of the battery, and the negative of the voltmeter is connected to the negative of the battery, right children? Now emitter, we know it measures the current flowing through the circuit. Emitter is going to measure the current flowing through the circuit, and emitter is always connected in series. Why it is connected in series? Because it has to measure the total current flowing through the circuit. Right? So, and moreover, the resistance of the emitter is very low. So as its resistance is low, resistance क्या होता है? Oppose current को oppose करने की ability, right? So the resistance of the emitter is very low. So the total current will flow through the circuit. The total current is going to flow through the emitter, and so it will measure, and so it is going to measure the total current. Right? So now the emitter is going to measure the total current in the circuit, and it is connected in series because it has low resistance, right? Now voltmeter over here. Now we know that voltmeter is connected in parallel. Why it is connected in parallel? Because beta, voltmeter has high resistance. Voltmeter current को बहुत ज़्यादा oppose करता है. It does not allow the current to pass through it easily. So what will happen if the current will not pass through the voltmeter? So if the current does not flow through the voltmeter, it is going to flow through the conductor. And when it is flowing through the conductor across this point, across this point and across this point, it will measure the potential difference, and very minimum current will pass through potential difference. So the entire current is going to flow through this conductor, right? So voltmeter is always connected in parallel because it has high resistance. It won't allow the current to pass through it. So the entire current is going to pass through the conductor, that is, this is your conductor. And so the voltmeter will measure the potential difference across the points. Let us name them XY. So voltmeter जो है वो potential difference measure करके बता देगा that across the point x y what is your potential difference, right? Now we know the direction of the current. The current will flow from positive through the circuit towards the negative. Right? So ammeter is a device which is used to measure current. It is connected in series because it has low resistance. Voltmeter is a device which is used to measure. Voltmeter is a device which is used to measure the potential difference, and it is always connected in parallel because it has high resistance and it will measure the potential difference across the conductor, that is across the conductor, that is or through point xy, right? So this is a ammeter, this is a voltmeter. Now what Mr. Ohm said that if we are having only one battery, suppose we are having over here only one battery, and the voltage of the battery, suppose I say the voltage of the battery initially V and I. Initially the voltage of the battery is suppose 5 volt. Voltage of the battery is 5 volt. Then in the experiment, okay, so voltage कितना है बेटा 5 volt. हमने जो battery connect की है that is of 5 volt. Now the current that is flowing through the circuit, that which we saw the reading in the ammeter, suppose it is 10 ampere. Suppose it is 10 ampere. Now beta, instead of putting one battery, I am connecting one more battery over here. यहाँ पे हमने एक की जगह we have connected two batteries now. So it is positive, negative, positive, negative. So we know two battery each of 5 volts. So now the total voltage will be 10 volts. Now the total voltage will be 10 volts. And we will note down the current from the ammeter. And we saw the reading of the current to be 20 ampere. We saw the reading of the current to be 20 ampere. Now what we are doing? अब हम एक और battery increase कर रहे हैं, right? We are putting one more battery. So now the total potential, let's see how much it will become. So one more positive, negative. So each battery is of 5 volt. So the total voltage कितना हो जाएगा बेटा 15 volt, right? So the total voltage is 15 volt, and then we will see the current in the ammeter. कि current कितना है ammeter में? And we saw the current in the ammeter to be 30 ampere. So the current in the ammeter to be 30 ampere. Now here we can observe that as the value of V is increasing 5, 10, 15, the value of the current is also increasing 10, 20, 30. right? So now if we find out the ratio of V by I, if we are dividing V upon I, that is 5 by 10 is how much? Half. 5 by 10 is how much, beta? Right? 10 by 20 is how much? Half. 15 by 30 is how much? Half. Half is what? 0.5. Can I write 0.5 instead of this? So this is 0.5. So we will see that the value of V upon I is constant. Half, half and half. So the value of V by I is constant. Right? So as we are increasing the voltage, as we are increasing this voltage, the current in the circuit also increases, and we can see that the ratio of V by I is constant. Right? So this is your statement for Ohm's law. This ratio, that is V by I, which remains constant, and we found in our case it to be half, that is 0.5. This value is remaining constant. So this is it is termed as resistance, that is electrical resistance, right? So let's see what Mr. Ohm has said. So, according to Mr. Ohm, according to George Simon Ohm, he found out that the potential difference across a conductor is directly proportional to the current flowing through the conductor, right? So as we increase the potential, from 5 volt to 10 volt to 10 volt, from 10 volt to 15 volt, the current also increases. So we can say that V is directly proportional to I. And we know that if we remove the proportional sign, then equal to sign will come and a constant will appear. This constant is your resistance. That is known as electrical resistance. Right? We saw the value of electrical resistance R equals to V by I, and which we found that V by I was a constant. We found that R equals to V upon I, that is a constant. Right, children? Now, if we draw the graph of I versus V, so here we can see a graph of I versus V. So, we found that the graph of I versus V was a straight line graph which was passing through origin. So, it is a straight line graph passing through origin. So, the straight line graph proves that V is directly proportional to I. As we are going to increase the value of potential difference across the wire, across the conductor, the value of current will increase. So this is your law, right? It's very, very important. Now, let's understand resistance in detail. Now, here you will see that we are going to talk about resistance, right? Now, what is resistance? Resistance, that is the property of a conductor to oppose the flow of current through it. मतलब खुद में से करंट को रोकना कि करंट I won't allow you to pass through me, so that is resistance. As we say na, okay, obstruction, opposition, so these are the synonyms to resistance. To obstruct, to oppose the flow of current, to oppose the flow of current through it is the resistance. So here you can see in this picture that voltage is the supporter of current. It is going to push the current go. But here, yes, resistance, that is ohm. No, 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 I won't allow you to go. So the resistance is opposing, it is trying to stop. So this is what do you mean by the resistance. So electrical resistance is the property of the conductor to obstruct, to oppose the flow of charges, flow of current through it. So now the resistance value, it depends upon the nature of the conductor, whether your material of which your wire is made, whether it is a metal, right, whether it is a conductor, whether it is an alloy, you have done in class 10, or whether it is an insulator, right? It depends upon nature. So if it is a metal, if it is a conductor, then in conductor the resistance will be less. In conductor the resistance, conductor में बेटा resistance जो होगा that would be conductor, the resistance will be less. But in insulators, we know insulators, they do not have free electrons, right? So वहाँ पे तो resistance बहुत ज़्यादा होगा. Current is not allowed only to flow in a insulator, right? Next we are going to talk about is dimension. So resistance, it depends upon the length, it depends upon the breadth, it depends upon the area of your wire. आपने वायर कैसे सिलेक्ट किया, whether it is thin wire or whether your wire is thin or your wire is thick. So it will depend upon the dimensions of your conductor, and lastly it will depend upon the temperature of the conductor. आपकी जो wire है उसका temperature क्या है, whether you have heated the wire and you have placed. So resistance is the property of the material to oppose the flow of current through it, and it depends upon the nature of the conductor, it depends upon the dimension, that is the length and the area, and it depends upon the temperature of the conductor, right? So with the name of the scientist George Simon Ohm, the SI unit for R, that is resistance, has been named as ohm. So whenever you write ohm, you are going to write with small OHM, small OHM. आप small OHM ही लिखेंगे, right? But do not write the symbol SI unit with capital O. Capital O would be the name of the scientist, right? But when SI unit of ohm is asked, you have to write with the small letter OHM, or you can use the symbol that is this. This is known as ohm. Now let's move to the next topic, that is electrical resistivity. So electrical resistivity, now we know that the resistance, depends upon length. So resistance is beta for resistance, this is not resistivity, we are talking about resistance still, right? Resistance, it depends upon length, right? If the length of the wire is long, and here you are having a short wire, right, of same area, ये length ज़्यादा है, ये length कम है. So what will happen? Inside this wire, we know there are positive ions and free electrons. And inside them, what happens? The positive ions are over here. These are your positive ions. बहुत सारे positive ions होते हैं, and we have electrons, the free electrons. And these electrons, they are going to move. They are in random motion, right? So when we are connecting a battery, this electrons, the free electrons, they are going to suffer more number of collisions. वो ज़्यादा टकराएंगे because the length of the wire is more. So when the length of the wire is more, the number of collisions that are suffered by the free electrons will be more. So collision ज़्यादा है बेटा, then resistance, that is opposition, उसके motion को, is obviously more. So when the length of the wire is more, the resistance will be more, and when the length of the wire is less, the resistance is less. So resistance is directly proportional to length of the wire. Short wire resistance will be less, long wire resistance will be more. Let's talk about the second term, that is R is inversely proportional to 1 by A, where A is the cross-sectional area. Where A is the cross-sectional area. By cross-sectional area, what do we mean? Suppose beta, this is your wire. Yeah, this is a wire. We are taking one wire is this, and of the same length, we are taking one more wire which is thick. इससे thick है, right beta? These are the two wires. They are of the same material and they are of the same length. Their length is also same, but this is your thin wire and this is your thick wire. So The wire which is thin, its area. Area is length into breadth, right? Its area in terms of wire, we can talk about area will be pi r square, right? So, so your for this wire, area for this wire is less, right? So if area is less beta, then what will happen for a shorter wire inside the thin wire? So let me draw a thin wire. ये बेटा ये this is your thin wire. So inside this thin wire there are positive ions, right? And there are free electrons. So what will happen? The area is very small. Oh God. So suppose your full class, I put you in a very small room, right? For example, our school pantry room, right? If I put you there, then what will happen? If the room area is small, but the number of students are, suppose it's 100. If 100 students I put you over there, then the number of collisions, the number of arguments, the number of your fighting, everything is going to increase. So the opposition increases. So because as the area is less, the number of collisions the free electron is going to suffer will be more, right? वहाँ पे बहुत सारे electrons है, बहुत सारे positive ions है. What will happen? The opposition will be more. बहुत ज़्यादा collisions हो जाएंगे. And so क्यों? Because area is small. Now, if I remove you from that very small room, and if I put you in our school's auditorium, right, very big, right? If I put you over there, that is quite a big space. Now the opposition among yourself, now the collision with that 100 students would be less. So this is why thick wire. Now inside the thick wire, the positive ions are here, the electrons are here. So the number of collisions as the area increases, वो कम हो जाएंगे because they are having quite enough amount of space. So if the area is less, beta, if the area is less, then the resistance will be more, right? So you can see that area and resistance, they are inversely proportional to each other. So from this we came to know that R is directly proportional to the length of conductor and R is inversely proportional to the area of the conductor. Right, and if we combine these two equations, we will get R is proportional to L by A. And here proportional sign if we remove, we will get a constant, and this constant is known as rho, that is rho L by A. So here the proportional constant, that is rho, that is known as your electrical resistivity. यहाँ पे भी ये बेटा जो rho है, right? This is what? This is your electrical resistivity. So what is electrical resistivity? If I take here the length of the conductor, बेटा अगर हम length 1 meter ले लेते हैं, if we take the area 1 meter square, then the resistivity will be equal to resistance, right? सबकी value हमने 1 ले ली and we are going to define electrical resistivity. Electrical resistivity को हम define करना चाह रहे हैं, right? So we can write like this, that is, I write it over here, that is 1 ohm equal to rho into 1 meter length upon 1 meter square area. 1 meter square area. So can I define this electrical resistivity as, it is defined as the resistance of the material. वो क्या हो जाएगा बेटा? Material का resistance हो जाएगा. What it will be? Electrical resistivity, that is equal to the resistance of the material. And what type of conductor you are having? We are having the conductor whose length is 1 meter and whose area is 1 meter square. So 1 meter length मतलब unit length, 1 meter square area मतलब unit area. So our definition for electrical resistivity will become, it is defined as the resistance of a material, that is rho equals to R when you are having unit length and you are having unit area of cross section, and the unit of resistivity, as we know, R equals to rho L by A. So if we make rho subject of formula, that is R A by L. R unit is ohm, area unit is meter square, and upon meter. So 1 meter gets cancelled, 1 meter gets cancelled, and we are left with ohm meter. We are left with is ohm meter. So ohm meter is the SI unit of electrical resistivity. Ohm meter is the SI unit of electrical resistivity. Right? Now let's talk about the next topic. That is your electrical resistivity. So it is what? It is defined as the resistance of material, right? Now resistivity depends upon what? Resistivity depends only on the type of material, right? It does not depend upon shape, it does not depend upon size. Shape size पे depend नहीं करती है, उसकी length कितनी है, उसका area कितना है. No, resistivity does not depend upon that. Resistivity वो कंडक्टर की वो मटेरियल की प्रॉपर्टी होती है, राइट? फॉर एग्जाम्पल इफ यू टॉक अबाउट इंसुलेटर्स, एलॉय, सेमीकंडक्टर और कंडक्टर्स. सो रेजिस्टिविटी किसी भी मटेरियल की खुद की प्रॉपर्टी होती है, राइट? टू डू व्हाट? टू गिव ऑपोजिशन, दैट इज योर रेजिस्टिविटी, राइट? सो रेजिस्टिविटी डिपेंड्स ओनली अपॉन दैट मटेरियल ऑफ the material of the body. It depends upon the material, किससे बना है, कंडक्टर से बना है, सेमीकंडक्टर से बना है, alloy से बना है, right children? And moreover, let's see over here, electrical resistivity, right? Electrical resistivity, we'll see on what factors does it depend. Quickly we will see this. Ohm's law, V equals to IR हमें पता है, right? Now I, that is your electrical current, we have derived, that is equals to NEAVD, where N is the current electron density, E is the charge on one electron, A is the area of your conductor, and VD is the drift velocity. ये हमने derive किया है last class में, right? Now your drift velocity, we know drift velocity is equals to E, capital E, tau upon M, where capital E is the electric field, tau is the relaxation time, and M is your mass of the electron, right? Now we have substituted this value. Now we know electric field equals to V by L, that is potential by length. So we are substituting the value of E as V by L. Now what will happen, beta? Over here, V over here and V over here will get cancelled. V gets cancelled, and we are making R subject of formula. And when we make R subject of formula, we will get this equation. यहाँ पे हमने L by A को अलग रख लिया है. L by A को हमने अलग रख लिया है, right बेटा? We know this equation also. R equals to rho L by A. So if we compare both the equations, then over here L by A, over here L by A. So rho will be equal to m ne square tau. Rho equals to m ne square tau. So here we can see that rho, this is constant. E square की value constant है. Value of E we know 1.6 into 10 to the power minus 19 coulomb. Right? M is what? M is the mass of the electron. इसकी value भी constant है. So इसका मतलब जो rho है, electrical resistivity है, वो किस पे depend करेगी? It only depends upon inversely proportional to the electron density. Electron density मतलब कितने electrons हैं per unit volume. छोटे से volume में कितने electrons हैं. And secondly, it will depend upon tau. Tau was the relaxation time. That is the time between two collision. दो collision के बीच का time जो होता है उसे बेटा बोलते हैं relaxation time tau. ये हमने किया है, right? अब this is what? This is your electron density. मतलब कितने electrons है per unit volume. तो conductor में free electrons per unit volume बहुत सारे होते हैं, right? Insulators में होते ही नहीं है. So जो कंडक्टर्स में बहुत सारे इलेक्ट्रॉन्स हैं, उसकी रेजिस्टिविटी बहुत ज्यादा है. So this is your tau, right? That is your relaxation time. तो जितना रिलैक्सेशन टाइम छोटा उतने कोलिजन ज्यादा होंगे, मतलब बहुत जल्दी 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 कोलाइड कर रहे हैं तो बहुत जल्दी जल्दी कोलाइड करेंगे, रिलैक्सेशन टाइम कम होगा तो उसकी रेजिस्टिविटी ज्यादा हो जाएगी. Next is your conductivity. So conductivity is just the ulta of resistivity. It is just the reciprocal of resistivity, right? Conductivity, the symbol is sigma. Sigma and resistivity का symbol हमने देखा अभी rho. So sigma equals to 1 by rho. और इसका यूनिट जो होगा, जो रेजिस्टिविटी का यूनिट है उसका उल्टा होगा. रेजिस्टिविटी का यूनिट हमें याद है ओम मीटर. So इसका उल्टा means 1 upon ohm meter. That is the SI unit of sigma. और 1 upon ohm को mho भी बोलते हैं. 1 upon ohm को ओम का उल्टा सिंबल ऐसे बना लो, यहाँ तो आप इधर that is ऐसे उल्टा बना लो, जैसे बोलते हैं mho and upon, right? So this is your conductivity. So conductivity is the inverse of resistivity. To resist, not to allow the current to flow through them, that is your resistivity. And the last topic is your conductance. Conductance means allow karna, acceptance, to conduct, come, flow through me, right? That is the conductance. So that is the reciprocal of resistance. Resistance was what? It was opposition, and conductance is allowing, right? So conductance is the inverse of resistance, and the conductance symbol is G, right? Equals to 1 by R. And its unit is the inverse of the unit of resistance. Resistance unit we know, it is ohm. So inverse of ohm, that is 1 by ohm. 1 by ohm can be written as mho. Or you can write ohm. Right, children? So this is with today's class. Fine. We'll end our class over here.